So example B, we've got it in standard form. There's no fractions and everything's lined up correctly. When I go to add, I get a 6x and a 7y, so nothing eliminated. So let's see, probably the easiest place is to change this and multiply by a -5 so that I can add to that +5 and get a 0. So I'm going to multiply through the top row by -5, and that will give me a -5x minus 20y equals, and then a negative, then 5 times 4 is 0, carry your 2, that's 70. Those are some big numbers. And then I'm going to copy over the second one, so 5x plus 3y equals to 2. I'm going to add them together. This is going to be 0, so this eliminates right there. I have a -20 and a +3, that's -17y is equal to -70 and 2 adds to be -68. So I need to solve that. I'm not going to be afraid of those numbers. And when I divide that, 17 will go into 68 4 times. So my answer comes out to be that y is equal to a negative, and a negative gives me a +4. So you have to be very careful about your signs when you're doing this. Very careful. So then I'm going to take my 4 and I'm going to plug it back into one of the original ones. So that's y is 4. So let's plug it into the second one this time. So I'm going to get 5x plus 3, and then y is 4. Make sure you plug it back into the right spot, is equal to 2. So 5x plus 12 is 2. Then we'll subtract 12 from both spots and get 5x, that's 0, is equal to 2, and -12 is -10. Then we're going to divide both sides by the 5, and that will give me x is equal to -2. So I have a solution of -2 and 4. Make sure you put your x first and your y second. We're going to check it. So let's do a check here. So -2 in for my x, and the first one's -2, plus 4 times 4 is 16, is equal to 14, and that checks. And then into the second one, it gives me -10 plus 12 is equal to 2, and that also checks. Example C is where the elimination method becomes very useful. Any of the others are nice with substitution, but this particular problem is not very nice with substitution. So the elimination method will be the way you want to go. But notice that, again, I can't easily eliminate anything. I also can't easily change a 3 into a 4 or a 2 into a 3. I can't easily change one of these into an opposite. So what I'm going to do now is I have a choice. I can either change these both into their LCM, which is 12, or change these both into 6s. And I'm going to choose this one because one's already positive and the other's negative. So I'm going to change these both to 6s because I can. So I'm going to multiply through the top row by a 2, so that changes this 3 into a 6. So that's going to give me 8x plus 6y is equal to -38. Then I'm going to multiply the next row by a 2, right? So I want to make a 6, no, by a 3. And that's going to give me 9x minus 6y equals -30. Now I'm going to add it, and that's going to give me 17x is equal to a -68. Oh, there's that again. So we already know that we can divide 17 on both and know that it goes into it evenly, and we come up with that x is equal to -4. So once we get -4, we'll plug back into one of the original ones. So I'll choose this bottom one. So I'm going to have then 3 times a -4 minus 2y is equal to -10. So that's -12 minus 2y equals -10. Then we're going to have to add 12 to both sides, and that will give us negative 2y is equal to 2. Then we'll divide both by the negative 2, and that will give us that y is equal to negative 1. So we have a solution. X goes first, negative 4, y second, negative 1, and there's our solution. We want to check it. So let's plug into the first one. Remember, you have to do both of them because it could work for one and not the other and not be a solution to the system. So we want to double check that. So we get negative 16 minus 3 equals negative 19. Check into the first one. The second one, that's going to give us negative 3 times negative 4 is negative 12. The negative 2 times negative 1 is plus 2 is equal to negative 10, and that also checks. So we have an answer.